Good day, everybody. Today we are going to be discussing reduction in trigonometry. Before we begin, let's look at our ratios. Our sine ratio is opposite over hypotenuse. Our cos ratio is adjacent over hypotenuse. And our tan ratio is opposite over adjacent. Our reciprocals is cosec, which is the inverse of sine. So it's hypotenuse over opposite. Sec is the reciprocal of cos, which is hypotenuse over adjacent. And cot is the reciprocal of tan, which is adjacent over opposite. I also wanted to remind you that if we look at our diagram, we can see that a complete revolution is 360 degrees. You know that from your geometry. With normal reduction, we work in an anti-clockwise direction. With negative reduction, we work in a clockwise direction. The next thing I'd like to do is look at our cos diagram. So if we look at this diagram here, we can see it's represented by, we like to say all stations to Cape Town or all stations to Claremont, but it means all the ratios are positive here. Only sine is positive here. Only tan is positive in the third quadrant, and cos and only cos is positive in the fourth quadrant. So let me label this. That's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right. So let's look at these quadrants in terms of positive reduction. If we look at the first quadrant, we normally refer to the first quadrant as theta or 90 minus theta. We refer to the second quadrant as 180 minus theta or 90 plus theta. The third quadrant is referred to as 180 plus theta or 270 minus theta. And the third quadrant is referred to 180 plus theta or 270 minus theta. And the fourth quadrant is referred to 360 degrees minus theta or 270 degrees plus theta. Now you may be asking, where do these references come from? Let's look at this angle. Can you see that this angle is 90 degrees? So all angles to the right of this 90 degree angle would be 90 minus your reference angle. And if we add another 90 degrees, that would give us a straight line. So in this quadrant, the angles would be referred to as 180 degrees minus theta or 90 degrees plus theta. Okay, so you see, we are either taking the 180 degrees and subtracting the angle, or we are taking the 90 degrees and adding the angle. That's how we refer to angles in the second quadrant. And then we have 270 degrees, so it would be 270 minus to the left, but 270 plus when we move towards the 0 or 360 degree line. Okay, do you understand that? So let's look at the following reduction. If I ask you to find the sine of 180 minus theta, what you need to do is say, in which quadrant is 180 minus theta? 180 minus theta is in the second quadrant. Then you're going to say in the second quadrant sine is positive. So that will give me positive sine theta. Let's do the second one. In the second one, we're going to say cos of 360 degrees minus theta. In which quadrant is that? That's in the fourth quadrant. And in the fourth quadrant, cos is positive. That will simplify into cos theta. Let's look at the third one. Tan of 180 degrees minus theta. Which quadrant? Second quadrant again. But in the second quadrant, tan is negative. Why is tan negative? Because the only thing that's positive in the second quadrant is sine. So in the second quadrant, tan and cos will be negative. So that will leave me with negative tan theta. And then sine of 360 degrees minus theta. Which quadrant? Fourth quadrant. In the fourth quadrant, sine is negative. Why? Because the only thing positive in the fourth quadrant is cos, which makes tan and sine negative. That leaves me with negative sine theta. Now let's look at the following sum and see if you can answer them by yourself without checking the solutions. And if I can give you one tip, it's when I'm doing reduction, I like to have my cos diagram on every single page so that I can reference firstly which quadrant I'm working with, and secondly whether that ratio is positive in that quadrant. So let's see, write down the sums and you can mark it when you are done. Don't forget to pause the video, and then when you are done you can unpause it and check your solutions. How did that go? I really hope you did well. Let's look at the next page. Okay, so the next thing that we are going to look at is cofunctions. Now what I want you to be aware of is that whenever you see 90 plus or minus theta or 270 degrees plus or minus theta, sine will become cos and cos will become sine. So let's look at sine of 90 plus theta. Sine of 90 plus theta is in which quadrant? It's in the second quadrant. And in the second quadrant, sine is positive. However, it reverts to cofunction and it will become cos. So your answer will be cos theta. Okay, let's look at another one. Cos of 270 minus theta. Which quadrant is that in? Where's 270 minus theta? It's in the third quadrant. And in the third quadrant, cos is negative. However, cos becomes the cofunction because it says 270 minus, and therefore it will be minus sine theta. Thirdly, let's look at cos of 90 plus theta. Now, 90 plus theta is in the second quadrant, and in the second quadrant, cos is negative. And we know that cos will become sine, so our answer will be negative sine theta. Now let's look at a more complex example. Tan of 180 minus x divided by sine of 90 minus x times the sine of 180 plus x. So what we need to do now is we need to simplify as far as we can. The one thing that I want to bring to your attention though, something that you learn later on in identities, is that tan is equal to sine over cos. So sometimes when we see tan, we'll need to replace it with sine over cos, and that tan squared of any angle is the same thing as sine squared over cos squared. So let's look at that first one, tan of 180 minus x. Let's place it, which quadrant? It's in the second quadrant. And tan in the second quadrant is negative. That will give us minus tan x. Sine of 90 minus x is in which quadrant? First quadrant. And in the first quadrant, sine is positive. However, because it's a cofunction, it will become cos, leaving us with cos x times sine of 180 plus x. Which quadrant is this in? That's in the third quadrant. And in the third quadrant, sine is negative, leaving us with negative sine x. So what does that give us? It gives us negative tan x over cos x times negative sine x. So let's change that tan into sine over cos divided by cos times sine. Now, what you guys know is that when we divide, we multiply by the inverse. Do you remember that? When we did division in primary school, when we divide, even in high school, you did it in grade 8 and grade 9 with fractions. So when we divide, we've got to multiply by the inverse. So what do we do here? We take sine over cos, there's sine over cos, and we've got to multiply it now by 1 over cos times sine. Okay. That concept of multiplying by the inverse is called tip and times. Okay, so we've got sine over cos times 1 over cos times sine. The sine will cancel the sine. And what are we left with? We're left with 1 over cos squared. Let's look at another example. We have cos of 180 degrees plus x plus 2 sine of 90 minus x divided by the sine of 90 minus x minus the cos of 180 minus x. Okay, so what does that give us? Let's work it out one at a time, because whenever we face these big sums, they seem to be a little bit overwhelming. But if we work them out one term at a time, it's really not that bad. So let's look at cos of 180 plus x. Which quadrant is that? It's in the third quadrant. And cos in the third quadrant is negative. So that's negative cos x. 2 sine of 90 minus x. Which quadrant is that in? That's in the first quadrant. Sine in the first quadrant is positive. However, it becomes cos. So that leaves us with 2 cos x. Let's look at our denominator. Sine of 90 minus x. Also in the first quadrant. Sine in the first quadrant is positive. So that leaves us with cos x. And then minus cos of 180 minus x. Which quadrant is that? That's in the second quadrant. And in the second quadrant, cos is negative. So what does that give us? It gives us minus cos x. So we've got minus cos plus 2 cos, which will give us positive cos x. And cos x, negative times a negative is a positive. And that will give us cos x plus cos x, which is 2 cos x. The cos x will cancel cos x, and what are we left with? We're left with a half. That's the end of today's lesson. I hope you've enjoyed this. Thank you for watching with us, and we hope to see you again soon.